Hi everyone, welcome back. Next, let us discuss the dependency injection. As already known, one of the core feature of Spring Framework is dependency injection. So what is dependency injection? Dependency injection is an approach in which the framework takes care of creating the object for us without we having to worry about providing the right ingredients or parameters to create the dependent object. So what is the advantage of it? So the advantage is you avoid the tight dependency on the objects on which you are dependent. See, let us consider an example to discuss this out. Take a look at the snippet of the code which is required to send an email. Let us assume this class is available to us either as a source code or as a jar file, and say it is a third party one which is provided to us, and we will be using this in our source code at multiple places to send the emails. So as a developer, we have the tendency of directly creating the object. So let us assume this person class is ours and we want to send an email. So what do? We directly create an object of it, and we have the tendency of directly invoking that send email object. In this way, the email object is used in a number of places in our source code. So is this fine? Means yes, it works fine, but there are a number of disadvantages here. Here, email is a third party class which is subject to change in future. So what is the problem with this? So what could be the reasons why you need changes? See, one reason can be, let us assume instead of email, you want to replace it with fast email, which is provided by maybe the same vendor or some other vendor, either for technical reason or business reason. In this case, you need to go and change the different places where you have created the email object in your source code. Next, let us assume the email constructor is accepting additional arguments, maybe with the settings of the SMTP server or maybe some other details. In this case as well, you need to go and change the source code in all the places where you are using email. Next, let us assume a decision is taken to make the email class singleton. Here as well, it need multiple changes. So let us try to see this dependency diagrammatically to get more insight. As you see here, we have different classes, class 1 to class 100 in our source code, and we are dependent on the third party, which is an email class, where we are directly creating the object of email and we are using its functionality. So it's not necessarily be a third party, it can be even the internal one, and which is subject to change more frequently. See, this is called tight dependency. So whenever you have a tight dependency and there are any changes on the dependent of for the dependent object, then you are forced to go and change the source code from class 1 to class 100. So what is the time required? What is the cost of it? And what is the testing effort? And what is the time to market? So all these are the disadvantages. So what is the solution for this? Is using Spring Framework. Now let us see diagrammatically how the Spring Framework will help us avoiding the tight dependency on the dependent object. So let us consider we have an email class on which we are dependent, which is a third party class. And this class 1 to 100 are our classes. And we have a Spring core which is the dependency injection framework we will be relying on. So let us see how we are dependent on the Spring framework to create the instance of email instead of we creating. See, as we see in this diagram, the class 100, class 1 to 100 do not directly create the object of email class. Rather, we interact with the Spring DI framework and we ask the Spring, create and give me the instance of email class. So what Spring Dependency Injection Framework does is, it goes and sees, as shown in the step 2, it goes and sees in the XML file. See, the XML file is the place where we specify the list of all the classes whose instances can be created by the Spring DI framework. So whenever you ask that you want an instance, see, in Spring terminology, we call an object as a bean. A bean is nothing but it is an object which is being created and managed by the Spring framework. So as you see in step 1, we ask the Spring framework, give a bean of so and so class. So the Spring framework goes and checks in the XML file whether that bean is registered. So each bean will have an ID associated with it, and there will be a class name along with the package name. So the Spring framework gets the name of the class, and further that specific class is being loaded in the runtime on the fly. See, here we do not have the tied dependency with the email class. In case there are any changes in the email class, or you want to change the email class itself, very simple, just go and change the XML file. You need not go and change the source code of class 1 to 100. So using dependency injection, we can make sure that the source code changes are very minimal to 0. Thereby we avoid the tight dependency. So what is a bean? As already said, a bean is an object that is instantiated, assembled, and managed by the Spring DI framework. All the beans are registered in the XML file in the application, and we use a bean tag, XML tag, to specify each bean details. Now let us check an example for the same. So this is an example which uses Spring DI functionality. See, the first and foremost thing is, let's go and check the pom.xml file. As we see here, the first and foremost thing is, we need to specify that we are dependent on the Spring framework, Spring context. Basically, that has the main Spring core, and Spring core obviously has the dependency injection within that. So this is the first requirement. Next, where is the main application? See, this is the main application. You can give any name for this file. And to keep it simple, I have considered a simple console-based application so that we focus only on the dependency injection and get more clarity. See, this main application is considered as our source code, the business application source code, and we are assuming that we are dependent on employee and XYZ email. See, in this specific example, I have directly included the source code of employee.java and XYZ email.java. But in the real application, it may happen that both of them are put in a jar file, and that is a third-party code, and we do not have the source code available, but we may have the jar dependency. So anyhow, we need to register all the bean classes in an XML file. You can give any name to the XML file, and you need to specify the XML file in the main application.java. See, here is the place where we specify the XML file name. Now let's go and see what is there in this XML file. So as we were discussing, this XML file has the list of all bean classes. So primarily it has three details of each bean. One is ID of the bean. Next, the class of a bean. Here we have put in a default package, but ideally it need to be in a package, and you need to specify the full name including the package and subpackage. And generally we use the scope as prototype, and we'll be discussing more about prototype in coming sessions. And see, whichever employee class which you are creating, that expects a constructor argument which is an integer. And whenever you specify this, automatically the Spring framework invokes the setter method on this bean to give this value. See, here we are giving these fixed values from the XML file, but in a real life application, it may happen that you want to provide the details yourself, maybe from the front end or wherever. So we will be exploring that in the next sessions. So these are the details of one bean, and here we are considering one more bean. So the ID of the bean is mail, the class is XYZ email, and the scope is prototype. See, as we see here, it is not mandatory to provide the constructor arguments or the setter arguments. It is required only if it is expected by the bean class. Let us get into the main application. See, before getting into the main application, let us take a quick look of the bean classes. See, here we have the source code, but it may happen that we do not have the source code and we are just provided with the API references and a jar file. So we can include the jar file in our project by going to the build path and adding, or in the Maven dependencies. Okay, so an employee is nothing but it is a simple Pojo class, and the same with XYZ email. Now let's get into the main application. As already told, we are considering a simple console based application so that we can focus only on the dependency injection. See, the first and foremost thing is we need to specify the XML so that the Spring framework refers this XML to load the required bean classes. And we make use of the bean factory. Using this bean factory, we try to get the beans. See, this E is nothing but it is the ID of the bean class. So it returns as an object. We are typecasting and we have the bean reference, yes, which can be eventually used in the application. So the same is with get bean mail. As we have seen in the application context.xml, mail is basically the ID of the XYZ email. So we are using XYZ email here, and further using the functionality of. So let us try to run this application. So as we see here, first this employee bean gets loaded and this constructor is invoked and the set name is invoked. So both of them happen whenever the employee bean is getting created. So as we have specified the constructor, so it invokes the constructor of employee which takes one integer argument. And here we have the set name will get invoked automatically. So it may also happen that there are multiple constructor arguments and multiple setter methods. And if you find any mismatch between these property names or constructor arguments, then you will get an exception, not the compiler error. The reason is all this matching is done in the runtime. So there is a small performance hit. Okay, right. So let's try to make a small change in the application. So what I'll be doing is, see, I'll just try to change the name here so that there is a mismatch between these and the setter method in the employee.java. Okay, so I have the set name and the field is name. So let us assume unknowingly I am trying to use some other name for the property. So what it will do is it will try to invoke set name kjk. Okay, so let us see what happens. Let me try to run main application.java. So as we see here, we get an exception and not a compiler error. The reason is the entire matching, reading the XML file, loading the bean classes, and you use get bean to load that specific bean. All this happens in the runtime, not during the compile time. Okay, so there is a small performance hit when you're requesting for the bean and okay, and try to interact with that. So whenever you get any exception like that, very simple, just go to the firstmost exception. And generally you get the hint at the last part of that first line. See, it is telling invalid property name kjk bean class. Fine, right? So this is a shortcut. So rather than exploring all the exceptions, you can go to the firstmost line of the exception and check the last part of it. Okay, in case you do not get here, then you need to explore the other part of the exception messages. So let me try to go and change it back to name. See, this name is basically the name of the prop, the name of the field in the employee class data member. Okay, right. This name is basically the XML attribute. Okay, so let me go and try to run it again. Yes, it is working fine.